Okay, good afternoon, class. So today we're looking at exercise 7.11. At this point we have concluded exercise 6.8, 9 and 10. So if you have an issue with this general solution, you have to first go to exercise 6.8, 9, 10 and 11. Okay. Today we're looking at more complex trigonometric equations. These are the examples for exercise 7.11, which is on page 247. Okay. So we have dealt with a general solution of equations and their solution in specific intervals in the previous chapter, which is chapter 6. Which is that what I've highlighted 6.8 to 6.11. We will now incorporate the skills learned in this chapter into solving trigonometric equations. So it's very similar to the general solution, and given the specific domain there, the specific interval, here we have just added the reduction formula. Okay. So this is example 1 on page. Okay. So the question says, given the general solution of the equation 2 sine 180 minus theta times cos of theta plus cos of 90 minus theta is equal to 0. And where do I start here? I first have to use reduction formula. Okay? So going to the first case here, 180 minus puts you in which quadrant? Your quadrant 2. Is sine positive or negative in quadrant 2? Positive. So it's 2 sine theta times cos of theta. Nothing happens here, remains cos of theta. Now 90 minus theta is in which quadrant? 1. Is that cos positive or negative? What changes to? Okay. So what do we notice now? Got a common factor of sine theta. What are we left with? 2 cos theta plus 1 is equal to 0. Now what do we do? If we have x is equal to 0 and 2x plus y is equal to 0, 2x plus 1 is equal to 0, so what do we do? That's give you the answer. So remember, if we have x into 2x plus 1 is equal to 0. Now the question wants to solve for x. What do we do? X is equal to 0 or 2x plus 1 is equal to 0. Not so. So because this is now in that format, is in the 0 factor rule format, I now say that sine of theta is equal to 0 or 2 cos theta plus 1 is equal to 0. Alright, so what do I do now? We take it over. Becomes cos of theta is equal to negative half. So what do we notice? We can now go with general solution in each case. You all agree with that? So something to note at this point is that if we have 0, 1 and or minus 1 in this place here, what do? We take it to the graph, and we spoke about that in 6.11. So we draw the sine graph. Why sine? Because this is sine. So where's sine x equal to 0? At 0, 180 and 360. Can you see that, people? So how do I write that as a solution? Or a general solution? I say theta is equal to 0 plus k times, and how many degrees is going to happen every? 180 degrees. Okay. So any confusion there? Let's look at the other one. So here, you calculate the reference angle, not so. So reference theta is equal to r cos of a half. Or if you know that that is coming from a special triangle, not so. So it's 1, 2, root 3. And when it's cos a half, if it's adjacent of upper, so you're going to have to be 60. You all agree with that? Otherwise, if you didn't know that, no problem. You've got r cos, or shift cos of a half. Remember, I'm dropping the negative. It's 60 degrees. Anyway. Okay. So which question comes to mind in that stage? In which quadrant is cos? Negative. Just before we took the r cos. So in which quadrant is cos negative? 2 and 3. So how do I get into quadrant 2? So it's going to be theta is equal to 180. Quadrant 2, my girl. Minus what? 60 plus k times? Why k times 360? Sorry? The period on the cos graph is 360. So what's 180 minus 60? 120 plus k times 360. Or the quadrant 3. How do you get the quadrant 3? Theta is equal to 180 plus 60 plus k times 360. So that's going to give you 240 plus k times 360. What did I forget to write here? What I should not forget, to write k is an element of. Writing it once at any of the branches suffice for both. If you're that kind of girl that wants to do it twice, you can write it here and here. It doesn't matter. Was there a restricted domain here? No, they asked you for the general solution, so that's where I stop. Yes. 7. Okay. Sometimes 6. This goes up until 9 marks. I've seen a 9 mark question. Okay. It's easy, no? When you see somebody else do it. When you do it yourself, you do it for it. You guys just practice this stuff. It's worth a lot of marks in your exam. Assalamualaikum. Thanks, man. Example 2. Example 2 is on the same page, correct? Yes. No. So example 2 again, it says find the general, or give the general solution of the equation. Sine 360 degrees plus x equal to cos 180 minus x. Okay, where do we start? We start by reducing, using a reduction formula, not so. The all stations to clear one. 360 plus is in which quadrant? 360 plus. Quadrant 1. Is sine positive or negative? So sine x equals 180 minus which quadrant is that in? 2. Is cos positive or negative? Negative. Cos. So sine x is equal to negative cos x. What's going to happen here? Take cos to the other side out. She says you don't know. Okay, if you take cos to the other side, you're going to get sine of x plus cos of x is equal to 0. Now what? Nothing, okay? Anyone else? Divide by cos x. Why cos x? Why not by sin x? Why didn't you divide both sides by sin x? Well done, you can read from the textbook, I like it. So you divide both sides by cos x. And of course sine over cos is 10. Okay. People is 10. Sorry. If I had sine 2x equals cos 2x. I could have divided both sides by cos 2x. Not so. To get tan 2x is equal to 1. Okay. What if I add sine alpha is equal to tan, sorry, not tan, but cos beta. And I divide both sides by cos beta. That is 1, but would this give me tan of alpha and beta? No. Okay, you see that? That will remain like it. The reason why this can become tan is because the angles are the same. And that is what you look for there. Are the angles the same? If it is the same, I can go and get tan on that side. You guys understand? Is there any confusion there? So we're going to get, of course, tan x is equal to negative 1. So what do we do now? Arctan of 1 is going to give you, remember I'm dropping the negative, 45 degrees. That also comes from the special triangle. So if it says without using a calculator, you don't show this line. If you're using a calculator, okay? That is being scanned, okay? But you don't show this. Or make it a habit of not showing it. It doesn't matter. Okay? So what question comes to mind, people? In which quadrant is tan? Negative. And in which quadrant is tan negative? 2 and 4. But what did we say about the tan? Just write one of the two branches, okay? So we're only going to write it for quadrant 2. So quadrant 2 is going to be, how do we get in quadrant 2? So it's x is equal to 180, this is the reference x. No? So it's 180 minus 45 plus k times 180. Why k times 180? Because the period on the tan graph is 180. And what's 180 minus 45? 135 plus k times. Where k is an element of? Five marks or something. 4 or 5 marks. Sorry? When do you know when to divide? If you've got sine x and cos x. The angles are the same. I can reduce it to one angle. There's another way you could have done this, but that is covered in exercise 7.12. The next exercise. Any other confusion? Anyone else that's confused? Look at example 3. Example 3 is on page 247. Given the general solution of the equation 2x squared, 2 sine squared alpha plus cos alpha minus 1 is equal to 0. Well, what does this remind you of? What do you see here? Quadratic. But if x is y, if x is sine and y is cos, then we're having something looking like this: 2y squared plus, 2x squared plus y minus 1. So could I have factorized that? No, it has to be in the same variable, not so. So is sine alpha the same variable as cos alpha? No. So one of two. So what we need to do here is we either need to change sine to cos or cos to sine. But could I change this cos of alpha? Could we have changed that? No. But we can change sine squared alpha. And sine squared alpha can be written as what? 1 minus cos squared alpha. For those of you who are confused, sine squared alpha plus cos squared alpha is equal to 1. And sine squared alpha is also equal to 1 minus cos squared alpha. You see that? And that is what I'm going to use here. Okay? So what will we be reading now? 2 into 1 minus cos squared alpha plus cos alpha minus 1 is equal to 0. So what do I do now? Put it out the brackets, not so. So what do we get? 2 minus plus cos alpha minus 1 is equal to 0. Now what do we do? Add like terms. Lay everything to the other side, so 0, that becomes positive 2 cos squared alpha minus cos alpha. What is 2 minus 1? Take it over, becomes minus 1. Okay. Trinomial. That's going to give me 2 cos alpha minus, cos alpha. It must be minus 1 plus 1. Okay, now there's some of you that can't factorize it like it, not so? So what we do is, we now replace cos squared with, and cos with an x. So it's 2x squared minus x minus 1 is equal to 0. So either use a quadratic equation, complete the square, or the calculator. Factorize your trinomial, so it's 2x, x1 and 1. That must be negative, positive. You see, so you got 2 cos alpha plus 1, cos alpha minus 1. Can you see that, people? If you use a quadratic formula, no problem, you would have gone straight, and then this would not have been there. You don't have to show your substitution, so you just say x is equal to minus half, or x is equal to 1. You guys understand? If you go straight into this here, it's going to be, of course, cos of alpha is equal to negative half, or cos of alpha is equal to. But I have answered the question of the general solution. So what do I do, people? If I have 1, look at that. If I have 1, 0 or minus 1, what do we do with that? Take it to the graph. Which graph are we going to draw for this one? The first graph. So see at 1. That's negative 3, it's 360. 0, 1, minus 1. So where's sine of x equal, where's cos of alpha equal to 1? At 0. Or at 360. But you see that if you say 0 plus k times 360, I'm actually including this one here. You all see that? Because if you got, if I had a general solution for the 0, 1, what will this general solution be? Alpha is equal to 0 plus k times 360. And we look here. If I put k is equal to 1 in here, what's 0 plus 360? 360, which is that solution there. So I don't have to represent it again. You guys understand? This to come this side here. Which cos of alpha equals negative half. But what do we do with the negative? Drop the negative. No? So again, that's coming from a special triangle here. There's 30, 60, 1, 2, root 3. So cos of what is half? 60. So the alpha angle is 60. That's a reference. Okay. So which question comes to mind? Which question should come to mind, people? Which quadrant, yes? It's cos? Negative. And which quadrant is cos negative? Quadrant 2 and 3. How do we get the quadrant 2? 180 minus 60. So alpha is equal to 180 minus 60 plus k times 360. So alpha is equal to 120 plus k times 360. 4. How do you get the quadrant 3? So it's 180 plus 60. Plus k times 360. So I'm going to give you 240 plus k times 360. Where k is an element of? Okay, was there any confusion? Huh? Yes? Sorry? Which the first step? This one here? You see that when I started off the question, I asked you, what do you see here? So you see there? Trinomial. Huh? So there the sign is being squared. So for me to factorize a trinomial to get it in a zero factor format, this variables has to be the same, because if I had 2x squared plus y minus 1 is equal to 0, could I have factorized this trinomial sign? You can't. So we must get it in the same same format, with the same trig ratio. There has to be the same variable. You understand? So if you're looking at xy, is xy the same variable as xz? Are those variables the same? No. So we must get it exactly the same. Not so. So if you're looking at the variables here, I know that I can either change sine to cos or cos to sine. Okay. But if you look here, that I can't change to sine of alpha. So that one has to stay. However, for the square, I know I can change the square. Was I? Sine squared alpha is equal to 1 minus cos squared alpha. The golden rule was. The squared I did it here. So what I did was I replaced sine squared alpha with 1 minus cos squared alpha. And then I multiply the two in to get rid of the brackets. I then added like terms. 2 minus 1 is 1. You take 1 over, becomes a minus 1. We took that also over, became positive. We took that over, became negative. What you now see here is a trinomial in the form of 0 is equal to 2x squared minus x minus 1, which now I can factorize into 2x and x, 1 and 1, minus plus. And wherever I saw x, I put a cos alpha. So it's 2 cos alpha plus 1 and cos alpha minus 1. And then I just did my general solution. Okay. So any other confusion? Any other confusion, people? Right, so that basically brings us to the end of the examples for exercise 7.11.